Yes, I'm talking about the alkali metals. In the periodic table, alkali metals the first group. In alkali metals have been categorized because the outer shell of alkali metals 1. Actually, in periodic table, everything have been categorized according to the outer shell. Okay, and the attitudes, characteristics of alkali metals, they are subsolid with low melting and densities. Okay, and if alkali metals, I'm just telling the name of alkali metals: lithium, sodium, potassium, rubidium, okay, cesium, francium. If these metals would be cut, the cross-section area will be seen silvery surface. If the alkali metal will be cut, the cross-section will be silver surface, freshly cut. If the alkali metal will be freshly cut, the cross-section area will be looking as a silver color. The interesting matter, alkali metals are very low melting power. They have low melting power, but they are reactive. They are highly reactive. Even with oxygen and normal existing oxygen and water, they react. As they are very reactive, normally they are kept in oil. Why? Because in normal situation, alkali metal start reacting with oxygen, existing oxygen and vapor, water. So they are preserved in a oil. And it is very interesting that as alkali metal go down, I mean, the least reactive is lithium. The second one is potassium, is more reactive in comparison to the lithium. As that go down, that become more reactive. Why? Because as the atomic number of lithium is only 3 and sodium is 11, as the atomic number are increasing from the nucleus, the outer shell is becoming further, becoming away from the nucleus. As the outer shell are becoming away from the nucleus, from the center, so the outer shell, they are losing the control. When son, daughter, they become away from the parents, they become less control. So as the downside, the alkali metals, outer shell is 1, but these one are becoming away from the nucleus. As the size of the downside alkali metal, suppose francium, the atomic number of francium is 87. After electronic configuration, the outer shell of francium also 1. But this one is very far away from the nucleus. So the control over this francium is very little. So francium is, in comparison to the lithium, francium is most reactive in the world. As francium is most reactive, francium cannot exist on this world 5 minutes. Its half-life is very little because this is most reactive. Interesting matter, as these are becoming very reactive, so its melting point also very high. This is natural because as the downside are becoming reactive, so with using little temperature, that can be melted because this is the natural situation. Francium, okay. And you know that this is traditionally the alkali metal being mixed up, alkali metal plus water will be the metal oxide plus hydrogen. What about the name? Alkali metals, any alkali metals, sodium with water will be sodium hydroxide plus hydrogen, lithium hydroxide plus hydrogen. So what about the name of alkali metals being with water? That will be metal oxide plus hydrogen. This is the natural characteristics. So you have understood, as the alkali metals, the outer shell of alkali metals is 1 because this is in the periodic table 1. Okay, most observing metal, the downside you are going down, these are becoming most reactive. Why? Because this outer shell 1 is becoming far away from the middle. So these are the properties, characteristics of metal, alkali metal. There are 8 groups, right? According to the group, each group, the categorically same attitudes, metal or non-metal, have been categorized. Exactly in group, same types of attitudes, same properties, metals or non-metals have been categorized. This is called group.